Hey guys, Miss Fearing here. Welcome to Unit 7, Notes 4. In this learning target, we are going to go ahead and we are going to review some basic probabilities. So you've seen a lot of this, but hopefully it'll come back to you a little faster. So a couple things about probability. When I am looking for a probability, I am looking for a measure or an estimation of how likely something is going to happen. So how likely is it that if I flip a coin, I'm going to get a heads? Probabilities are going to be given to us is a value between 0 and 1. 0 means that it is a chance that it's not going to happen at all. The closer that number gets to 1, the more and more probable it will happen. So close to 1, it's more of a 100% chance that it's going to happen. When you see this notation right here, P parenthesis A, we read that as the probability of A. So if you see that, I'm asking you to find the probability of A happening. So to find that probability is a fraction for us. And when we do that, we find the number of successes divided by the total possible outcomes. So we can kind of look at the top as the number of things we want. Like if I want a heads, how many ways can I get that? Number of things we want. And then the bottom again is the total possible outcomes. So let's go ahead and look at a probability using a number cube or a dice here. So if you're not familiar with a number cube or a dice, we just have one of them. So it has the numbers 1, 2, 3, 4, 5, and 6. Those are my possible outcomes of a number dice or a number cube or a number dice. So if I'm trying to find the probability of rolling a 1, how many ways can I get a 1 on this dice? Well, there's only one 1, so I can only get it one way. The possible outcomes I have, I could get a 1, 2, 3, 4, 5, or 6, so I have 6 different possible outcomes. So based off of probability being a fraction or creating a fraction using what we want divided by the total numbers, I would do 1 divided by 6. And since this is reduced, I could leave it this way, but what you want to start getting used to is you want to divide that in your calculator and get a decimal. So when I do 1 divided by 6, I get 0.166666, right? But we are going to round this to the third number, or third decimal spot. So that's going to be 0.167. Looking at our next example here, I want the probability of rolling a 2 or a 3. I would be happy with a 2 or a 3. So there are 2 ways to make me happy. I could get a 2 or I could get a 3. And there's one of each of those on that number dice. There are still only 6 possible ways. So creating my fraction, I get 2 over 6. I would want to reduce this if I was going to leave it as a fraction to 1 over 3. But remember, we want to get used to writing these as decimals, and we go 3 numbers after the decimal, so I would get 0.333. Now, probability of rolling an even number. Well, the even numbers that are on the dice are 2, 4, and 6. So there's 3 even numbers. There's 3 ways to make me happy out of 6 total. So create that fraction, 3 out of 6. Same thing as 1/2, which we know as 0.5 or 0.5 as a decimal. Probability of rolling a number more than 2. Well, numbers more than 2, not 2, doesn't include 2. I want numbers more than 2. So I can get a 3, a 4, a 5, or a 6. So there's 4 ways to make me happy out of 6 total. So 4 out of 6. If we reduce that down, we get 2 out of 3, which again, as a decimal, is going to be 0.667. Last one here, probability of rolling a prime number. So we want to remind ourselves, what is a prime number? A prime number has only 2 factors. So a number with only 2 factors, and those factors are 1 and itself. So when we think of our prime numbers on this number dice here, we have 1, which people think is prime, but 1 only has 1 factor, 1. So that is not a prime number. 2 is a prime number because we can do only 2 times 1. 3 is a prime number. 4 is not because it has the factors of 1, 2, and 4. 5 is, and 6 is not because I get 1, 2, 3, and 6. So there are 3 prime numbers on a number dice out of 6 total. So 3 out of 6, which gives me, again, 1/2 as a decimal, 0.5. So now we're going to go ahead and we're going to look at probability with a deck of cards. So just because I'm not sure how familiar you guys are with decks of cards, we're going to kind of look at breaking it down and talking about how many of each type of card there are. So really important for us to know, there are 4 different suits that we're going to deal with. We're going to deal with clubs, diamonds, hearts, and spades. So there's 4 different suits, which means there's 4 different cards of each type. I have 4 different aces, 4 different 2s, 4 different 3s. Basically what that means is there are going to then be 52 cards total. There's 52 cards total because I have 13 cards in each suit. Okay, so I have 13 clubs total. I have 13 diamonds, 13 hearts, and 13 spades. And when I add those all up, I get 52 total cards. So that's kind of what we're talking about for those. If I go ahead and I look at this, if I am talking about a face card, I am talking about my Jack, Queen, and Kings because they literally have faces on them. So these are my face cards. So I have 12 of them. I have 3 of each, 4 suits. So 3 times 4 is where I get my 12 from. So I have 12 total of those face cards. Now, numbered cards. Numbered cards are cards that actually have numbers on them. So we don't include the ace on those. Only the 2 through 10 are my numbered cards because those are the only ones that have numbers on them. So that gives me 9 in each suit. So I would get 9 times my 4 suits, which is where my 36 comes from. So when we talk about numbered cards, you're not including the ace on there because there is no number on that card. Last thing you're going to kind of have to know is how many of each color there are. Well, when we have a deck of cards and we have 52 total, we literally split the deck in half for our black cards and our red cards. So we have 2 suits that are black. Our clubs and our spades are black. So that's 13 times 2, which is where I got the 26 there. And then my red cards are, again, 2 suits. So 13 times 2, which gave me 26 there. So hopefully that helps you fill out that little table there. Cards per suit, there's 13. Cards of each type, there's 4. Cards in a deck, there's 52 total. Face cards, there's 12, because remember we're looking at the ones with the faces. Numbered cards, there's 36, because again we want just the ones with the numbers on them. And then for red and black, there's 26 red and 26 black. So let's go ahead and look at some probability with cards on this table here. So first thing I'm looking for is probability of getting a spade. Well, if I remember correctly, the spade is a type of suit, so there are 13 of those. And possible outcomes, I have 52 cards in that deck. So my probability is 13 out of 52. Reduce that down, I get 1 out of 4, which as a fraction, or as a decimal, is going to be 0.25. When I'm looking for my aces, if I go back and I look at that picture, there's 4 aces in a deck of cards. It doesn't matter what suit it is. I would take any of them. I just want an ace. So there's 4 out of 52 total. 4 out of 52. Reduced down is 1 out of 13, which as a decimal is 0.077. If I want a red card, well, half of my deck is red, so 26 cards are red out of 52. So it'd be 26 out of 52, which we said reduced down was a half of the deck. So I'd get 0.5 as my decimal. Now, I want the Jack of Clubs. That is the only card that will make me happy, just the Jack of Clubs. So looking in my deck, there's only one of those out of 52. So 1 out of 52, that's reduced down as far as it can go. So we're just going to plug it into our calculator and get a decimal. I get 0.019. And then last thing here, I'm looking for a face card. Remember, face cards are the ones with the faces. So there's only 12 of them out of 52. Create that fraction, 12 out of 52. That's going to equal 3 out of 13, which is going to give me 0.231. So the last thing we're going to talk about before we jump into some examples here is something called a complement probability. So when we are talking about complement probabilities, we're talking about probabilities that add to 1. So basically, if you find the probability of A happening, and then you find the probability of A not happening, when you add those together, you would get 1. So the probability of it happening and the probability of it not happening are complement probabilities. Together, they would be 100%. So let's look at our first example then. So we have a bag with 3 red marbles, 2 green marbles, and 5 blue marbles. We want to find the probability of randomly grabbing a blue marble. So remember, we are doing the things that I want, number of the things that I want, divided by the total number. So total number. So I want to grab a blue marble. So in this bag, I have 5 blue marbles. Total then, I have 3 plus 2 plus 5. So 3 plus 2 plus 5 gives me 10 total. So reduced down is 1 over 2, which as a decimal is 0.5. So the probability of me grabbing a blue marble in this example is half. Half of them are 50%. So example number 2 here, you decide you want to read Harry Potter. You go to your bookshelf and randomly pick one of them. What is the probability you do not choose the first book in this series? Couple things we need to know. There are 7 total books in the Harry Potter. Okay? If you didn't know that, now you know there's 7 total in the Harry Potter series. So it is asking me to find out the probability that I do not, that is a big word, do not choose the first book in the series. So I will take the 2nd, the 3rd, the 4th, the 5th, the 6th, or the 7th. So there are 6 of them that I would take out of the 7 total. Plug that into your calculator to get a decimal, you get 0.857. Next example, a bowl contains 2 green, 10 blue, and 8 red stones. If 2 stones are chosen at random from the bowl, what is the probability that it is not green? I do not want green, so I will take a blue or a red, but I don't want a green. So if I'll take a blue or a red, I have 10 blue and 8 red, so I have 18 of them that I would be happy with. And then out of the total number, so I have 2 more then, so that would give me 20 total. Plug that into your calculator, you're going to get 0.9. Number 4 here, you need to make a doctor's appointment next week. So we want to find the probability that it's on a weekday. Well, think of your days. We got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. I want it to be on a weekday. So if I'm looking at my weekdays, that's going to be my Monday, Tuesday, Wednesday, Thursday, or Friday. So I would take 1, 2, 3, 4, 5 of those days would make me happy because I want it on a weekday. And there are 7 total. Plugging that in, I get 0.714. Almost to our last example here. Number 5, there are 4 male and 6 female puppies at a breeder. We want to find the probability that you're going to get a female puppy. So the female puppies are going to make me happy. So there's 6 of those. Out of the total number we have available, there's 10 total, 4 plus 6. Reduce that down, I would get 3 over 5, which as a decimal would be 0.06. This is our last example here. I want you to go ahead and try this one on your own. Be careful, it's asking that the card is not a diamond. So find the probability that the card is not a diamond. Pause the video, try it on your own, come back and check your answer. So when I did this, I actually looked at my picture. I wanted the probability of it not being a diamond. Well, I know that there's 52 cards total, and 13 of them are diamonds. So I did 52 minus 13 to figure out how many of them were not diamonds. So 39 of them are not diamonds out of 52. So when I plugged that in, I got 0.75. If you didn't get that or you're still kind of unsure of how this all works, please come chat with me before moving on to your practice.